All right, more probability, 12.3. We're still doing experimental, so actual trials, real data that we collected. But we're going to do compound events today. So I can find the experimental probability of compound. Forgot my O down here. Compound events. So a compound event is an event that is a combination of two or more single events. So two or more outcomes. So it's like if I rolled a dice and flipped a coin. So two things happening at the same time. I could even roll a dice, flip a coin, and spin a spinner. Three things. And then I would have multiple outcomes. Okay? So, means we're going to be doing a little bit more data. Definitely get your calculators so we can do some adding, some dividing. So a food trailer serves chicken and records the order size. So 2 pieces or 3 pieces, and the sides of the order: green salad, mac and cheese, french fries, or coleslaw, and it shows it in the table. What is the experimental probability that the next order is for 3 pieces and coleslaw? So if we put those together, that's the data. But just like on our 12.2, we need the total. So what we have to do is add all of these up. The total is the 33 plus the 22 plus the 52 plus the 35. You can see why we need a calculator. Hopefully you can do this with me. All right, so add all those together. Check to see what we got. I got 330. Check me. So once we have the total, pause, check me. Once we have the total, we can then write experimental probability. So our probability of 3 pieces, we'll put 3 ply, and coleslaw would be 55 out of 330. But now we have to reduce this. So we can reduce them by 5 because they both, right, would be divisible by 5. We, trying to think what else we can divide by. I think 5 again. But if we reduce this all the way down, we actually get 1/6. Oh, it's divided by 11. We can divide these both by 11. Then by 5. So that's how we get 1/6. Divide by 11, divide by 5, we get 1/6. Alrighty. So here's another one. Drink sales for an afternoon of school carnival were recorded on the table. What's the experimental probability? The next drink is a small cocoa. So small cocoa, get them together, that's this one. We need that total though. So pause, find the total, find the experimental probability, reduce. Okay, I want you to pause. I want you to do all of it. See if you can match mine and see if you can find that probability of a small cocoa on your own before I do it. So when you add these numbers together, we should have gotten an even 400. We would do 60 over 400. You could divide by 2. You could divide by 10. You can divide by 5. But we do have to reduce it. So once you reduce, you get 3 over 20. 3 over 20. Okay, check your reducing, check your calculator, divide those numbers till you can get it as small as you possibly can. Remember, reducing is just dividing by something that's the same thing, right? Divide by 10, both of these. Divide by 5, both of these. Okay, if you need a refresher, put it in the questions. Okay, I need a refresher on reducing. All right, same thing. That's what's really nice about this. We just do the same thing over and over and over again. A dentist has 400 male and female patients that range in ages from 10 years old to 50 years old and up as shown in the table. What is the experimental probability the next patient will be female and age range 22 to 39? What's really nice about this one, it already told us the total. No adding on this one. So let's see if you can again pause and you figure out what the numerator is this time. I'm not going to circle anything, but we're looking for females and range of 22 to 39. Pause. See if you can do this. This is where the good practice comes in. Pause, pause, pause. So we want probability of, oh, too many lines. Female, age 22 to 39. So there's my female, there's my range, it would be this. So we would have 50 over 400. So I could divide this by 10, get 5 over 40, and then divide by 5, and we would get 1/8. So hopefully that's what you got too, 1/8. All right. So once again, what is the experimental probability that the next customer buys a red notebook with 150 pages? So go find your total. You gotta add all these up, add, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Get your total. And then let's find the probability of a red notebook with 150 pages. All right, consider this like an extra problem. I am not going to do any of this. You need to put your answer in your form. We're going to go over it in class, but I am not going to finish this problem. Okay, not going to finish it. All right, so things to remember. This is still experimental probability. So a compound event is still number of events over total trials. So it's exactly the same, except we'll just have a little bit more info, more choices than before. All right, your independent practice is, Jenny says the experimental probability that 7th grade students read at least 100 pages per week. She says it's 16. This is her answer, 16 out of 125. What is her error and the correct experimental probability? So you need to go and find the experimental probability, but also explain what's wrong with her answer. Okay, so they are telling you Jenny's probability is wrong. Why? All right, until next time.